another example on proving trig identities. So guys, as you will see that the challenge level is going to increase as we go from number 1 all the way up to number 7. Here I have another one, and you can see there's a left hand side, there's a right hand side, and we want to make sure that they are actually equal to each other. In order to do that, we already know that we have to probably start with one of the sides. Sometimes we may have to use both the sides, but most of the times we start with one of the sides, whether it's left hand side or the right hand side, and then we simplify, use the identities, and try to simplify it to look like the other side. So in this case, again, you can see that there's two sides. There's a left hand side, there's a right hand side. Guys, the right hand side can be simplified as well, but if you look at this carefully, we'll see that there's more stuff going on the left hand side. There's more room for simplification on the left hand side, so it would make sense for us to actually start with the left hand side and then make that look like the right hand side. Okay, so that is our first starting step. Even before trying to write anything, we first look at the problem, and then from there we figure out which side we want to work with. Here again, it's the left hand side. In the first problem it was left hand side as well. So let us start with the left hand side and see how we can simplify using the algebraic methods and also using the trig identities. Okay guys, for me personally, this is a lot of fun because it gives me an opportunity to use algebra skills and the identities and everything. I really enjoy doing it. Once you get a groove of it, guys, I'm sure you will also enjoy doing it. So just try to go over these examples, then try to do these ones first on your own, and then you will be able to do more from your textbooks and other places on your own as well. Okay, so let us start with the left hand side. Obviously we can see this is the left hand side. So what we're going to do is we're going to try to simplify or substitute values for some of these trig functions. Like tangent, we know, is sine over cosine, and cotangent is cosine over sine. Again, that is pretty basic, right? Or if you are not sure about those, guys, again, look at the formula sheet. Okay, so the left hand side is going to look like this. 1 plus tangent, I'm going to replace by sine over cosine. Okay, the most basic one. Tangent is the ratio of sine over cosine, and cotangent is the ratio of cosine over sine. Okay, and this downstairs I have 1 plus cosine theta over sine theta. Right, that is my denominator. Okay, now from here let us just focus on the numerator piece. We want to combine these two. So in order to combine, we already know that we got to have a common denominator. So you got to have a common denominator means I got to have a cosine theta here. So if I get a cosine theta here in the denominator of 1, then I got to multiply this by cosine theta as well. We know how the creating a common denominator works, right? And finally, we will end up with something which I'm going to write in the next step. And same thing we're going to do with the denominator piece as well. Okay, so it's going to look like this: cosine theta over cosine theta plus sine theta over cosine theta, and then this whole thing is divided by, guys, same thing here, got to multiply and divide by, here I want to create a sine theta, so I'm going to have a sine theta here and multiply this by sine theta. Okay, not too difficult, just the basic algebraic principle of creating a common denominator. So the downstairs is going to look like this: sine theta over sine theta, which we know is 1, and that is this 1, and then plus, but we are doing it to just combine two things together, plus cosine theta and sine theta. Okay, from here let us take it up here. The denominators are the same, cosine and cosine. Can we combine the upstairs, the numerators? And the answer to that is yes, we can now combine them. So if I combine them, it's going to look like cosine theta plus sine theta divided by the cosine theta, whole thing divided by, and we do the exact same thing with the denominator. You have a common sine theta here, you can combine the numerator, it's sine theta plus cosine theta over sine theta. So far so good, guys. I have this this big division here, and we know when we have fraction divided by another fraction, we like to convert this or transform this into a multiplication, and when we do that, this is going to flip, right? So it's going to look like this: cosine theta plus sine theta, let me put it in parentheses, divided by cosine theta, and then times, right? Times, this is going to reciprocate, right? So it's going to be sine theta divided by, instead of writing sine theta plus cosine theta, I can write it cosine theta plus sine theta, right? The basic additive principle, a plus b is same as b plus a, right? Now let us see if we can simplify some things. Guys, obviously this and this are the same, they are like terms, and we are dividing them. So what's going to happen? A quantity divided by itself, it just like crosses out, or you can think of this as like getting a 1 here. 1 times sine theta is sine theta over cosine theta. Well, looking at this, let us ask ourselves, does this look like this? Well, if you just look at this, maybe it does not right now look like that, but we can still do something more with this to make it look like that, okay? Again, going to the basics. Guys, the basics means the basic formulas. We know, because the right hand side is in terms of the secant and cosecant, not sine or cosine, but we know what is sine and what is cosine, right? In terms of, we know what is sine in terms of the cosecant, because they are reciprocals. And we know what is cosine in terms of the secant. Again, they are reciprocals. So sine theta is 1 over cosecant theta, because they are reciprocals of each other, right? And then what is the cosine theta in terms of the secant? It is 1 over secant theta. So guys, let me tell you one quick thing. So once I simplify all this and I get this, then I'm not going to just start writing stuff. I'm not just going to start looking at the formula sheet and start doing things. No. Once I get this, when I get to this point, I went back to the right hand side and I saw like what is actually right hand side looking like. And I can see that the right hand side has a secant and cosecant. That gave me a clue that I should try to find this formula or identity from the formula sheet or things that you already know, where I have sine. Is there anything about sine in terms of the cosecant or cosine in terms of the secant? And the answer to that is yes, they are reciprocal. So that's why I decided to use these identities, okay? So simplifying this further, it is going to be 1 over cosecant theta times, again, this division, converting it to a multiplication. This is going to flip, reciprocate, secant theta over 1. Ones don't matter, or you can just cross them out, and when you simplify this guy, it becomes secant theta over cosecant theta, and that is exactly what the right hand side looks like. So we were able to prove the identity that this equals to that, starting by works with the left hand side and then simplifying and using some trig identities, and finally getting it look exactly like the right hand side. And again, you know, the whole last thing is like implies the left hand side equals to the right hand side, and that implies, because we actually did all the work to show that this actually transforms to this ratio, which is exactly what the right hand side is. Guys, this was number 2. The challenge level is going to go up, and it's going to be a different type in my next example. So far you have 2 examples. Please practice these, and then I will see you in the next video with the 3rd example.